is very common, but it's just creating trouble for them. So use all of this. Yeah, again, just apply your common sense. You'll be fine. But yeah, what we're doing here was we're visiting the BBC homepage and we're getting all hyperlinks. So that's going to include things like the news articles, but it's also going to include other things that we don't care about. So things like contact pages and category pages and things like that. So um, from all of the hyperlinks, we want to kind of subset only those that lead to articles. And here the regular expression is much more simple, so you can kind of see what it does. So we have kind of the head. So all articles are going to start with this bbc.com/news/articles. And here we have our regular expression at the end, which is in regular expressions, dot stands for any character, and this little asterisk stands for as many characters as possible. So I think it's called greedy. Oh, I forget what it's called. In any case, it's matching everything after this article slash. So when we do that, you see we get a list of articles. And again, they're not that many. Let's see exactly how many they are. Length of BBC article links. So we have 37 articles, and these are the articles that have been published today that are on the front page of the BBC. Oh, these are the links that lead to those articles. So here we do a bit of data wrangling. We define an empty list, and we'll use this list to actually store the content of each article. But the important function for this example is this URL submit. URL submit is the main function that allows you to send asynchronous requests to web pages. And as you can imagine, we'll apply this URL submit function to the list of our articles. So we use this map here, shorthand for map, and we use our list of article links. But what goes inside URL submit is more interesting. So here we just have the slot that is going to take one of the links of the articles. And then we have handler functions. So obviously URL submit is going to submit a request, but we want to specify what we want to do with the response of that request and what event we are listening for. Again, you don't need to worry too much about that. In this case, we are waiting for this event called task finished. So after the request has been sent and after the response has been received, that's when a task is finished. And then after that, we do we essentially import the text of the XML object, and then again we use XML element to kind of extract a specific part of that XML object and append it to this empty list that we defined here. So to kind of summarize it, we're sending a request to each of the web page. Once we get the response, we get the content of the article, so the actual text of the article, and we append it to our empty list. So let's do that for each one of our articles. Let's give it a few seconds. And you can see that URL submit returns these task objects. And you can see that the task type is asynchronous. So what that means is this task object, this task object doesn't need to wait for the previous one. Oh, sorry, just trying to select this one. So this task object does not need to wait for the previous one to finish. They're all sent, or as many of them as our computer can handle are sent in parallel, and that means we don't have to. It greatly reduces, even with how many articles we have, even with 37 articles or however many we had, you can see that it took us like maybe 5-10 seconds. And if we just did that with a normal import, it would take much longer. So that's the kind of the main idea and the main advantage of using URL submit. Now the disadvantage is the syntax is a bit more complicated, but still it's nothing major really. Okay, so what have we done here? We have appended all the articles to this BBC article bodies variable. So let's see what that looks like now. Hopefully that should give us 37. Yeah, so we've successfully collected the text for each of the 37 articles, and now we have them in our variable called BBC article bodies. Again, we can do our word cloud if we want. So the last time we did it with the headlines, and this time we're doing it with the actual content of the articles. So you can see similar President Trump, Trump government, Gaza, just common things on the news nowadays. Um, what else do we do? Oh, we have a slightly more interesting example here. So once we have all of the text of the articles, we can look for specific things in that text. As you may be aware, there are these things in Wolfram language that we call entities, and entities could be, well, there are a lot of different entities. The ones we are looking at in this example are countries. So in Wolfram language, when you see this kind of orange box, that's an entity, and in this case, let's say the United Kingdom is the country of the United Kingdom, and they're not just simple strings, but they contain a lot of information about that country. So essentially, we have the string of the articles, and we are looking for anything that might be a country entity. And to do that, we use this text cases function, which looks at a simple unformatted string, and it tries to extract entities out of it. In this case, we're looking for countries. So let's do that and see. So this is going to, we're flattening also, we're creating a single string out of all the articles, and we're looking for all the countries that are mentioned in that string. So that takes a bit of time. So let's give it a few seconds. So all of that is done by Wolfram language. So there's no um, AI as we imagine it. There's no LLM. Um, Everything is done with kind of native Wolfram language functions. So the result is, as you see, it's just a list of all the countries that have been mentioned in the BBC articles, but now we have them as entities, and we'll see why that is important. So here it's a huge list actually, and some of them were unsuccessfully interpreted as entities, but we can just ignore that for the second. So the first thing we're going to do is we're going to count um, how many times, or we're going to count which ones are mentioned the most. So unsurprisingly, United States has been mentioned 207 times in today's news articles on the BBC. Ukraine has been mentioned 94 times, China 59, and so on and so on. Again, our word cloud, we like our word cloud, so we do it for the countries, so for the country names essentially. And you can see US, Ukraine, China, the top three. Something more interesting that we can do with our country entities is kind of plot these, use this geo bubble chart function, which plots a bubble on top of the country, and the size of the bubble represents the frequency of that country in our data set. So because the US has been mentioned the most times, it has the biggest bubble, and then you have things like places like Ukraine and China, and you can kind of have at a glance um, um, map view of which countries have been mentioned, how often they were mentioned, and so on. Um, what do we do here? We have a function that generates. Oh, this is kind of cool actually. So let me run this because it will take a few seconds as well. And while it's running, I will tell you what it does. So we had a list of the most frequent countries, right? If we go back here, we have a list of the most frequent ones. So we want to take the top three. So in this case, US, Ukraine, China. If we run this on a different day, it will be different countries, or maybe not because these are very common. Um, but for each of our top three countries, we are going to generate a separate word cloud, again with the word clouds. But the difference in this case is going to be that the word cloud for each country is going to be in the shape of that country. So we'll see what that looks like. Just give it a few minutes because it's doing a lot of kind of data cleaning, data parsing for each of the top three countries. So again, it will take a few seconds, but the output is quite cool. So I mentioned that it's going to use the shape of each country, but how do we know the shape of each country? Because as I mentioned, if we're doing this on a different date, we'll get different countries. So we can't really hard code the shape. We want to get it dynamically. We want to get it programmatically, so to speak. And that's one of the examples where having these entities instead of simple strings helps. So if we have this entity, United States, for example, there is a property. There are a lot of properties for each entity, but one of them is the shape of the country, and we leverage that kind of built-in knowledge in Wolfram language to get the shape. Uh, and once we have the entity, it's very easy to do. So let's see if we have our result. It's still working. But the property that gives us the shape, it's called, well, shape. Um, Hopefully that finishes soon. Oh yeah, here we have it. So obviously the top country was the US. So you can see um, for the articles that have mentioned the US, this is the word cloud of the most common terms, and it's in the shape of the US. So unsurprisingly, there's a lot of Trump's, the Ukraine, Gaza war, so on. Tariffs, for example. Then the next country we have is Ukraine. Again, unsurprisingly, all the kind of most frequent words are here. And then finally, we have, what is this? We have China. Do we have China? Is it? Yeah, this is China. So again, um, a little bit of fun to drive the point that once you have your data in, you can use any of the Wolfram language's functions to do anything you want, essentially. Um, Another thing that we're going to do is we're going to create a semantic search index, and we're going to use that with input to be embedded. Let me just see why we're getting an error. We're passing it again a full string of all the article bodies. Oh, I think it's because it's a list and some of them will be empty. So semantic search index is complaining. So let's do to string. Maybe this will work. Yeah. So we're using a function called create semantic search index. What that does is a kind of a similar idea to the LLM example functions, but in this case, we're creating a vector database that contains information from all the article or all the text from the articles from the BBC. And once we have the semantic search index with all the vectors, we can pass it to an LLM, and when we ask it question that's relevant to the information in the semantic search index, it can look at that and it can give us relevant responses. So let's see how that works in practice, because it's probably easier to understand once we actually try it. So here we've created the semantic search index. It contains all the articles. So let's ask it a question that's relevant. So let me go back to the most commonly mentioned countries, and let's pick one of the let's pick Kenya, for example. So we can ask our LLM, why has Kenya been in the news recently? Now, if you ask this to a normal LLM that doesn't have access to the internet, it's not going to give you any definite answer because it doesn't have that information. But since we have the text of all the articles and we're passing it to the LLM in the form of a vector database or semantic search index, um, anything related to that prompt is going to be highlighted to the LLM, and it's going to use that in its response. So here it's telling us the recent mention of African countries, including Lesotho and Kenya. Um, including Lesotho in the context of US aid under Trump's remark do not specify. Oh, actually, so I didn't get it. However, Kenya is also. I wonder if it's because I flattened the whole list. Let's try with Lesotho, because obviously it got this one. Maybe I need to fix this code. So this works. So it actually has been in the news recently due to comments made by former US President Donald Trump. Blah, blah, blah. He criticized the countries and so on. Not sure why it didn't work with Kenya, but this is the idea that you essentially create a database that the LLM can query and give you more relevant responses, rather if you asked it directly uh, without giving it a semantic search index. And we can compare that actually if we just ask it the same thing, but we remove the syntax which passes the semantic search index, it's going to give us a generic answer. Yeah, as you can see, this LLM's cutoff date is October 2021, and it's not able to give us any specific answers. But when we do it with the semantic search index, it can get that information from it. Again, a little example of how you can combine data that you got from an external source, in this case the PPC, how you can combine it with other functions to kind of build useful things. Hopefully that makes sense. Let's move on. All right. So we're getting to kind of slightly more complicated. Well, actually, conceptually, it's probably simpler because we are all used to visiting web pages via a browser. So conceptually, it's simpler. Programmatically, it's a bit more complex. So, but the main idea is we are going to start an actual browser, um, and we are going to kind of navigate it programmatically, and we'll use that. And you'll see what the advantage of that is. And mainly, actually, just to kind of foreshadow, the main advantage is that in some cases, so if you're dealing with just very simple web pages like the contact pages that we had for the different businesses, or the BBC News website, these are very kind of simple in terms of structure, static web pages that don't really change based on the user interaction. And for those web pages, you'll be fine just sending a simple import request, HTTP request, whatever it is, even URL submit. They do the same thing. But in some cases, you'll find that the web pages, for example, load content dynamically. So when you visit the web page, it doesn't show you anything, and then that content is loaded via some JavaScript, for example. So if you send an import request to a page like that, you are going to get an empty response because the JavaScript isn't loaded and there's nothing on the page. Most commonly, there are things like so you visit a web page and you get, let's say, the first 10 elements. And once you scroll down to the bottom, that's when the page loads up more elements and things like that. So in those cases, you need a web browser to kind of simulate that user interaction in order to get all the data from the web page. Again, once we get into the actual examples, it will make more sense, but this is the basic idea. So Mark is asking, do we have to pay for a separate service beyond the regular Mathematica license in order to use functions like LLM synthesize? The answer is yes, and that's a good question. I should have mentioned that. You have several options, but basically the basic answer is yes, you need to pay for LLM usage. You can either do it directly through Wolfram in the form of a monthly subscription. So I think our product is called LLM Kit plus Notebook Assistant. And how that works is it's just a flat monthly fee, and you get access to all the LLM related functionality in Mathematica. So you get LLM synthesize, as you just saw me use, LLM example functions. You also get things like the Notebook Assistant, chat personas, just everything LLM related. You get access with a flat monthly fee. Or you can go to one of the providers directly, for example, OpenAI or whoever your favorite provider is. You can register on their platforms, get an API key, and then input the API key in Mathematica. So that works as well. The difference with that is you need to pay per query, or you need to pay for your usage directly to the provider. It doesn't essentially nothing goes through Wolfram. So but in both cases, you get access to all the LLM functionality. So whichever way you want to do it, but you need one of those two ways of linking up to an LLM. It doesn't come with Mathematica itself. So that's a good question. I should have mentioned that when I was using the LLM functions. Okay, let's get back to automated browsers, parsing HTMLs. We are going to be using two main functions. One is start web session, which is actually going to launch our browser, and the other is web execute, which we are going to use to kind of manipulate that browser or to make it do different things. So here we're just starting a web session. So I think the supported browsers are Chrome and Firefox. Ideally, I think 9 times out of 10, this will work out of the box. So you don't need any, there's no setup involved in getting this functionality to work. I had some issues on my personal machine, but I think that was machine specific, because on this computer that we use to present webinars, it worked fine. I didn't have to do any setup, and I know other people don't have to do a setup. So the way you use it is calling this start web session function, and you specify the browser. So when you do that, you see that there's a Chrome window that opened up here. It's an empty window at the moment because we're not doing anything. But let me um, put that on the screen so we can, once we manipulate it, we can see in real time how we can manipulate it with code. But we're starting our web session and we're storing it in a variable. That's quite important because we're using, and this is kind of a very object-oriented programming type of workflow where we store some object in a variable and then we use that variable to kind of interact with that object. So in this case, we're storing it in session. Somebody's asking about Safari. Safari is not supported, unfortunately. I quite like Safari, but it's not supported out of the box. And yeah, it's just Chrome and Firefox, unfortunately. But I mean, they all do the same thing essentially. So is it? Let me make sure Safari is not supported. I said that very convincingly, but actually, I'm not sure. I'll just have a quick look at the documentation. No, it is. It is Chrome and Firefox. Yeah, not Safari, unfortunately. But okay, so we have this web session. We're storing it in our variable. So let's see how we can actually start manipulating it. Um, as I mentioned, the main function that we're going to use to manipulate our session is web execute, and excuse me, web execute takes a few arguments. So the first one is always going to be our session. So which browser we are kind of manipulating. And then after that, it's the actions that we want this session to take. So in this case, we're saying operate on the session that's stored in this variable. And what I want you to do is open a page. And this is the web page that you're going to open. Also, this is the example.com that we saw at the beginning. So let's evaluate that. And you can see on the right, our browser has navigated to that web page successfully. And you get this nice status message, in this case, success. So let's see, what are we actually going to do on this web page? So web execute, other than opening a page, which lets you navigate to a specific web page, obviously, web execute has a lot of other options that all kind of have a similar idea, similar goal, which allows you to extract some information from the web page that you're currently on. So once we have navigated to example.com, we're going to use web execute again, and we are going to pass it our session, and we're going to say locate the elements with the tag h1. So again, this is a bit of HTML. H1 tags are usually the title of the web page or some heading, or yeah, basically the top level heading of the web page. So we're getting the element in the h1 tag and we're storing it here. Now web execute returns web element objects, which need to be manipulated further if you want to extract, for example, the text from them, because you could do other things. Yeah, it's not just the text. You can, once you have this web element object, for example, you might want to click on it, you might want to hover over it, you might want to remove it from the web page. You can do anything you want with it, but in this case, we'll keep it simple and we'll just get the element text. Again, web execute our session. We want the element text of this element. So this is the element that we just found by the tag, and that is going to be the example domain. So this is the title of the web page, or the kind of the top level heading. Um, so yeah, this is a very simple web page. So there's not much else we can do on it. So let's navigate to something that's a bit more complicated. So again, we're using our session, opening a different web page, and in this case, it's a list of inspirational quotes. Again, it's one of those web pages that's designed specifically for web scraping training, but it looks more like a real page, right? Let me make this a bit bigger. It has different boxes, it has different quotes, it has authors, it has pages probably, which I'm not sure if we'll navigate in this example, but it looks like a real web page. So let's use it to extract the quotes. So again, I mentioned this earlier. How do we know what we want to extract? We use our browser tools, inspect in this case. Let me just do it again very quickly. Right click, inspect, brings up this pane here on the right. And the tool that we're interested in is this select an element. and we point at whatever we want to extract, and we can see where it is located in the HTML structure, because this is what we need to extract it. In this case, I've pointed at one of the quotes, and I can see that it's located in a tag called span that has a class of text, and it has this attribute called item prop, which again has a value of text. So this is all we need. So oh, here we're doing it step by step. Okay, so this is useful actually. So we are locating all elements that have a tag of span. So span is going to include things like our quotes, but it's probably going to include other things as well. But we are starting with this. So just to remove this, just so you can see, this is going to be a list of web element objects. Again, some of these are our quotes, some of them are not. So we'll do some further kind of cleaning up just to get the ones that we care about. We can look at the different attributes for each of these elements. Again, attributes is another HTML thing. But we're looking at whether for each of the spans, we're looking whether it has this attribute called item prompt. If it does, so this is just a simple if statement. If the span has this attribute of item prompt, we return it. If it doesn't, then it's not. It doesn't contain a quote, so we return nothing. So again, a bit of a helper function just to make sure we get the elements that we need. And then we can get all the span instances where the value of item prompt is text. So again, a bit of further cleaning just to make sure we get the element that we need. All of these kind of leverage the HTML structure. So you do need a very basic HTML knowledge. You need to know what a tag is or what an attribute is to kind of fully make use of those. But it's very simple. But all we've done is kind of dig into the structure and extract the elements that we care about. So finally, we have a list of all the quotes. And the next thing we're going to do is get all the authors, which are located in a different section of the HTML. So I'm not going to go through it in detail. As long as you know what we are doing. Again, we're looking at the HTML structure and we're leveraging that to get the authors. And then we put everything together. So we put the quotes together with the authors. And then once we have that data, again, we can do anything we want. In this case, we are getting a random quote out of the list. And the quote is, "The person, be it gentleman or lady, who has not pleasure in a good novel must be intolerably stupid." That's a quote by Jane Austen. So this was the kind of the simple example to introduce automated web browsers. Once you're done with your browser workflow, it's good practice to delete the object that stores your browser, just to make sure that it doesn't hang around in memory if you're not using it. So every time you're done with your automated web browser, just go delete object and pass it the session, and that closes the browser. But don't worry, we have more examples with browsers. So here we're going to actually start navigating more dynamic web pages. So we're going to start our web session, and you can see that start web session can accept an option called visible. And in this case, we're giving it to false. So once you have your workflows developed, you don't really care about the window, the actual window on your screen, because you'll be navigating the browser programmatically, so you don't need to see the window. But other than that, it behaves in the same way. There is a browser running. There's just no graphical representation of it. And here we're navigating to a simple Wikipedia page, which actually I probably should have shown you, but let me just open this in a normal browser. Open this. So what we want from this Wikipedia page is this table here, because it contains a lot of data and we want to do some analysis on it. And the data is blood type distribution by country. And I think it includes, oh no, it includes all the countries. Okay. So this is the web page we're navigating to. We are locating the table by its tag. We're extracting the relevant one. I think in this case, there are two tables on the page, and the second one is the one that contains the data. So this is what we're doing. Then we're doing some string cleaning. I'm not going to go through all of the options here, but essentially Let me see what the example. We are getting the proportion of A blood type in each of the countries. So all the code that you're seeing on your screen is just kind of string cleaning to get the information that we're interested in and to discard the information that we are not interested in. There's a lot of regular expressions here, so it's still text manipulation, but I'll just show you what the final result looks like. So once we have cleaned up all of our data, we get a percentage for each country, which represents what percentage of the population has an A blood type. And then we subset only the European countries, and we do that using Wolfram language entities again. And finally, we can plot that again on a map. So let me do that. I'm rushing through this example a little bit, but it's just because I have some cooler examples later on that I want to have time for. And I think as long as you see the end result, so this is proportion of people with A blood type. Let me make this a bit smaller. So proportion of people with A blood type, and this is just a map of Europe where different colors means different proportions. Again, same point. Once you have the data, you can use the built-in mathematical functions to produce beautiful plots. And again, once we're done with our workflow, we just delete the session. Again, if you're interested in the string cleaning part, by all means, have a look at the code. You can download the notebook, but it's just fairly standard string cleaning, data cleaning, and so on. Any materials on web scraping using Mathematica? There's not a lot, and this is exactly why I wanted to write this webinar. Um, but if you go, I would say probably the most useful place to look at is the documentation for web execute. There are a lot of examples, it lists all the options, and it's probably the most useful place for getting data from web pages, and hopefully this webinar as well. Okay, so this example here, again, we're going to be using an automated browser, but finally we're going to interact with some dynamic content. So this is why I wanted to get to this example more quickly, because it's actually quite interesting, I think. So again, we start our own web browser, and in this case, I probably should have done visible false, but let's fine, let's see it. It doesn't matter. And we navigate to this web page, which is let me reject the cookies. So the web page that you're seeing on the right of your screen is just a table containing all the tennis players, professional tennis players. So ATP is the Association of Tennis Professionals, and you have all the players, and you have different stats for each player. Um, that's very interesting. Well, anytime you see a table of data, I kind of get interested. I want to play around with it. But for the purposes of getting the information out of the web page, this one is interesting for several reasons. First, we have different tables. So you can see here on the top, we have stats related to serves, stats related to returns, and stats related to pressure, or how players perform under pressure. So we would need to navigate to each one of those. So that goes back to the question that somebody was asking in the beginning. What if we want to navigate to different pages? And we're going to do that here. And the other interesting thing is that if you scroll down to the bottom, there is this button called load more. So by default, we only see the first 50 players, but there are more than that. So if we want to get all of them, we need to click this button. Now, I'm not going to click it manually because I want to show you how you can do that programmatically. But these are kind of the two main things: navigating different web pages and clicking buttons. So we're doing something more than just getting text out of the. Obviously, we will be getting the table, but these other bits are more interesting. Um, so first of all, we're going to locate the button, and we're going to use the same strategy as we did previously. We're using locate elements, and we're finding it by its tag. Now, in this case, A is a very common tag, so it's going to find our button, but it's going to find a bunch of other stuff that we don't care about. So we need somehow to locate the A element that represents our button and discard um, all other A elements. So in this case, we're iterating over each one of them, and we're seeing which one has an element text or which one has a text that says load more. So that's only going to be our button, because you can see that this is the text. So for example, this subscribe button is also probably in a tag, but we're not going to match it because it says subscribe and not load more. So hopefully when we do that, we should only get one result. So let's have a look. Yep. So we got one web element object and we know that this is our button. So what we can do is we want to click on it. So we do web execute, and this time we're calling the option click element, and we're passing it our button. So let's do that. And as you can see, when we ran the code, the button was clicked and all the other players were loaded. So once we have all the players, then we can get the table because now we have the full table. Again, we do a bit of string cleaning just to extract the different stats from the table. Again, regular expressions, fairly standard stuff. And then we close our browser. And we are going to repeat that workflow for each of the 3 web pages that I showed you. So serve stats, return stats, and under pressure. And in this case, the reason why we close the browser and then open it again for the next web page is if we navigate to the web page directly from the same browser, we get asked to solve a captcha. So um, we get asked to select whatever fire hydrants out of some images to prove that we're human. Obviously, that's a bit more difficult to do. So, but I found that if I close the browser and open it again, I can avoid the captcha. So this is what I'm going to do for each of the 3 web pages. So that lets us get the data that we want um, without any problems. But the workflow itself is the same because these 3 pages look very similar. So we just open them, we click the load more button, then we get the table, and then we clean it up. And we have a 4th web page that looks slightly differently. So let's see what that looks like. So the 4th web page is just the rankings of the players. Um, Actually, I'm not sure if it looks differently. Maybe it's the same. Oh, the button is different because we still need to click a button. The logic, the code that we use is the same essentially. But in this cases, we're just getting their world ranks. So Sinner is rank number 1 and so on. Again, a bit of string cleaning. And a lot of the code in this example is just putting things together because we are getting data from 4 different web pages. So we have 4 different tables of data essentially, and we're putting them all together. And you see the code is, to be quite honest, the code is a bit horrible, but it does the job. So I'm not going to go line by line through it, but I can tell you what the main idea is. Once we have our 4 tables of data, we basically concatenate them into one, and we're doing a bit of data interpretation. So some of the columns are percentages, and some of the columns are texts, and so on. But this is what our data looks like once we have finished. Once we have finished with the scraping, so you can see that essentially it's a table that combines all the different tables that we saw on the web page. And again, that's very useful because once we have that, we can start comparing different things from different tables and so on. But that's the main idea. All right. So finally, I think we have one more example, which is also quite exciting. Let me just see, there's nothing more. Yeah. So this example, when I was testing just before the webinar, didn't really work in the same way that it did before, but I'll show you. I'll show you what it is, and I'll tell you how it's supposed to work normally. Again, it's one of those that I didn't. The web page has changed, so I didn't have time to kind of look at the new structure and fix the code. Again, starting our web session, Chrome, I'm putting that on the side as well. And what we're going to do, actually, I'll open this web page in a different browser just to show you what the problem that we're facing is. Let me just open this. And this is one of our Wolfram web pages. It's the example repository where anyone can submit their own. If you have a cool function, a cool workflow in Wolfram language, you can submit it to the example repository, and then anyone can access it. So if you have something cool, I encourage you to submit it to the repository first of all. But essentially, what we want to do is we want to see who has submitted the most examples, because for each of the examples at the bottom, you have information about the author. Um, where is it? Oh, contributed by, and in this case, it's Phileas Daisy Geist. I hope I pronounced that correctly. But essentially, we want to look at all of the examples and we want to see who has submitted the most. Um, so the problem that we have is we have this list of examples. That's fairly easy, but as you can see, not all of them are loaded. And the way this web page works is once we scroll to the bottom, it loads more examples. So what we want to do in our code is we want to scroll to the bottom before we actually get the links. So this is what we're going to do, and I'll show you how to do it. So let's open the web page first. Again, this is just the open page option, and we point it to the web page. And now we want to scroll down to the bottom so we can load the additional elements. Um, Unfortunately, there is no option that we can pass to web execute that says keep scrolling down. Because not only do we want to scroll to the bottom of the page, but once we do, we load more examples and then we need to scroll again to load even more. And we want to keep doing that until all of the examples are loaded. Now, obviously, that's a very specific thing. So there is no built-in option to do it. However, you can, once you have a browser open, you can execute any piece of JavaScript code in that browser, um, which basically gives you the power to do anything in that web page because JavaScript is very tightly integrated with web pages. So virtually anything you want to do in a web page will be achievable by JavaScript code. So here, this little piece of code that you see here is pure JavaScript. There's no Wolfram language code in it. But essentially, what it does is it kind of stores the size of the window in a variable. It scrolls to the bottom, and then it compares the size of the window to the previous size. So that means if new elements are loaded, the new size, so the size of the web page increases. So if the new size is higher, then it scrolls again, and it keeps doing that until the sizes are the same. Because once you load all the examples, if you scroll to the bottom, the size will remain the same, and that's how you know that you have reached essentially the end of the page. So it's a very simple JavaScript code that does that. Um, and what this does is it ensures that all of the examples are loaded. So let's do that and let's observe it as it keeps scrolling down. And now that it has reached the end, this is done, the loop breaks, and then we can continue with our workflow. Um, what we are going to do now is we're going to extract all the hyperlinks. So web execute does have a function for that, and it's very useful. So once we have loaded all the examples, each of them will be hyperlinks in the HTML, and we're going to use those hyperlinks to navigate to them. Now, what I mentioned, the part that doesn't quite work in this example, is previously when I got all the page hyperlinks from that web page, it included hyperlinks to all of the examples. It seems that the web page is updated now, so when you load in more examples, they take the place in the HTML, they take the place of the old ones. So currently, even though we have scrolled to the bottom, we only get, in the HTML, we only have the hyperlinks to these last few examples. We're going to run with that anyway. There will be a way to fix it. I just haven't had the time to do it. But normally when I run it before, I think you can see the result from the previous one. We had a few hundred examples, and in this case, we'll have like 10 or something like that. But the principle remains the same. Um, so from all the hyperlinks, we're going to extract the ones that lead to an actual demonstration, because there will be other hyperlinks. So would there be? Yeah, there will be things like wolfram.com here at the top. All of those are hyperlinks, but we don't really care about them. So we only get the ones that lead to demonstrations, and um, we know that they match this pattern, which again, regular expression, not going to go into it, but hopefully the idea is clear. And we define a helper function that is going to help us go to each of the demonstration web pages, and it's going to extract the author of that demonstration and it's going to store it in a list. Um, the way we do it, again, we'll locate elements, the option of web execute. This time, instead of looking for an HTML tag, we're looking for a CSS selector. Again, this is a bit of HTML knowledge, which is why I say that having a basic kind of foundational understanding of how HTML files, just how web pages are structured, will be a great benefit. But the principle is the same. We're looking for some way to find the data that we care about. In this case, the easiest way is by using a CSS selector. Once we find it, we just append it to our variable, and then we return. So this is, we're using do. So this is a loop that does that for every web page. It appends it to some variable, and then after the loop breaks, after the loop finishes, we return that variable. So as I mentioned, let's see, all resource links. I don't think we're going to have that many, just because the HTML offloads them once we scroll. But let's see how many we have. We have 25, so it's still a reasonable number of examples. So once we run this function, we'll see how our web browser is going to navigate to each one of the 25 examples. It's going to extract the author, it's going to append the author to our variable, and it's once it goes through all 25 of them, it's going to return them in a list. So let's do that now. And again, this will take a little bit, just because, well, in this case 25 should be fairly quickly, but if we did it with a few hundred like I had in the previous, when this was working properly, it takes a bit of time. And this is one of the examples where you might want to use URL submit. Again, if you're dealing with a few hundred web pages, that will be quicker. In this case, we just have 25. So we have collected all the authors in this variable. We can close our session, and we can just use our variable to do our further analysis. Here we're cleaning up some of the data, so some of the authors I think are malformed, but in any case, it's just simple data cleaning, and then we can tally up from the 25 examples that we had, who are the most common authors. Wolfram staff is on top with 19, Stephen Wolfram actually with 4, and then the quantum computation framework team with 2. Hold on, that's more than 25, isn't it? 19, 4. Oh no, it's 25. Sorry. For maths. And yeah, that's it. So between the simple HTTP requests that we started um, with things like import or URL read, and the async requests with URL submit, and the automated web browsers, you basically have all the tools you need to extract the data that you care about from any web page. As you saw, so which tool you use will depend on essentially the structure of the web page. If it's a web page that loads content dynamically, maybe you need to use a browser that will be a bit slower and obviously more resource intensive, but it lets you kind of lets you simulate a real user experience as far as the web page is concerned. If you're just extracting simple text from static web pages, then you'll be fine with import. If you have a lot of web pages, then you'll use URL submit for the speed that gives you, and so on. So if you need to do anything complicated on the web page, like clicking buttons or scrolling down, that's when you use, again, automated web browser, because you can inject any JavaScript code, which essentially means that you can do anything you want on the web page. But between these resources, I think there's quite a lot of useful things that, as somebody was mentioning, there's just not that many resources that kind of highlight this functionality. So hopefully this webinar gave you an idea of how you can use those different tools for your needs.